Hi, my name is Yang Woo-yoon of the Department of Electronic Information Engineering. I run this week that is about quantum mechanics. Quantum mechanics is the science of the very small. It explains the behavior of matter and its interactions with energy on the scale of atoms and subatomic particles. First, I run a write on a wave. Wave is three characteristics: interference, diffraction, refraction. Ray of light is considered to an electromagnetic wave with a given frequency. EXT is E0 sine kx minus omega t. K is wave number, omega is angular frequency. Omega is 2 pi f, it is 2 pi t. It is known for traveling wave. Speed of electromagnetic is c 3×10⁸ meter per sec. And Young's double-slit experiment. Double-slit experiment is a demonstration that light and matter can display characteristics of both classically defined waves and particles. Moreover, it displays the fundamentally probabilistic nature of quantum mechanical phenomena. A simpler form of the double-slit experiment was performed by Thomas Young. This is referred to as Young's experiment. In the basic version of this experiment, a coherent light source, such as a laser beam, illuminates a plate pierced by two parallel slits, and light passing through the slits is observed on a screen behind the plate. The wave nature of light causes the light wave passing through the two slits to interfere, producing bright and dark bands on the screen, a result that would not be expected if light consists of classical particles. However, the light is always found to be observed at the screen at discrete points. As individual particles, the interference pattern appearing via the varying density of these particle hits on the screen. Furthermore, versions of the experiment that include detectors at the slit find that each detected photon passes through one slit that include and not through both slits, as would a wave. However, such experiments demonstrate that particles do not form the interference pattern if one detects which slit they pass through. These results demonstrate the principle of wave-particle duality. The photons of light beam have a characteristic energy proportional to the frequency of the light. In the photoemission process, if one electron within some material absorbs the energy of one photon and acquires more energy than the work function of the material, it is ejected. And third, photoelectric effect. Photoelectric effect is electrons can absorb energy from photons when irradiated, but they usually follow an all or nothing principle. All of the energy from one photon must be absorbed and used to liberate one electron from atomic binding. If the photon energy is absorbed, some of the energy liberates the electron from the atom, and the rest contributes to the electron's kinetic energy as a free particle. And next, time-independent Schrödinger equation. General formula to describe wave-like behavior. Traveling wave Ex, t is E0 exponential j kx minus omega t is E0 exponential j kx E exponential minus j omega t. Ext is E0 sine kx minus omega t. Intensity of wave is ext square. So amplitude is black, intensity is red. Total energy is kinetic energy plus potential energy is mv square of 2 plus v is mv of 2 plus v. It is pvm of 2m plus v. P square of 2m plus v. We already know P is h bar k. Furthermore, total energy is h bar k square of 2m plus v.